started here the addressing mode and instruction set of 8086 microprocessor. First, we started the addressing mode of 8086 microprocessor. We already known about the addressing mode of 8085 microprocessor. Same as 8086 addressing mode in the different way in which the processor can access data to all the addressing modes. Now, how 8086 access the data? Instruction can be used to illustrate the addressing modes. How? There's a different types of addressing modes. The different way in which the source operate. This also we know that what is the output and what is the operand in an instruction of microprocessor. This in which a source operand is denoted in an instruction is known as the addressing modes. That is the first of all. We divide the addressing mode of 8085 in 8 parts. That is the first one is the register addressing modes. Same was the immediate addressing modes, direct addressing modes, register addressing modes, register indirect addressing modes, base addressing, index addressing, base index addressing, base index with replacement mode addressing. The first one, that is the register addressing mode. The instruction specify the name of the register which holds the data to be operand by the instruction. That means the register is the source of an operand for an instruction. That means register is the source of an operand for an instruction. This is the first example, that is the move CL, DH. The content of 8-bit register DH is moved to the another 8-bit register CL. That is the register addressing mode. Or you can example that is moved CX, AX. That is copies the content of 16-bit AX register into the 16-bit CX register. Just move the instruction, that is move AX, BX. That is the AX is the destination and BX is the source. That is copy a word or byte from a register, that is the BX register, into the 16-bit AX register. Same size and cannot both the memory location. Next one is the immediate addressing modes. In the immediate addressing mode, in which the data operand is a part of the instruction itself, is known as the immediate addressing mode. We also, when we know this immediate addressing mode in 8085 as the same, that is in the immediate addressing modes, the data operand is a part of the instruction itself. It's known as the immediate addressing modes. In 8085, we can use I for the immediate purpose, that is the MVI. But here, can use move as an example, let's move DL, 08H. That is 8-bit data given in 08 is given in the instruction is moved to the dual register. Move AX, 0A9FH. The 16-bit data is given in the instruction is moved to the AX register. That is the example of immediate addressing modes. Next, I'm going to the direct addressing modes. In the direct addressing modes, in which the effective address of the memory location is written directly in the instruction. The operand is stored, in which the data operand is stored, is given in the instruction. 16-bit number written directly in the instruction, that is move BX, 1354H. The square brackets around the 1354H denotes the content of the memory location where executed. The instruction will copy the content of the memory location into the BX register. In CULT, the direct because the displacement of the operand from the set main base is specified directly in the instruction. Next one is registered indirect addressing. In the registered indirect addressing, register which holds the effective address will specify in the instruction. That means the addressing modes allows the data to be addressed at the memory location through an offset address held in the following register BP, BX, DI. Suppose that move CX, BX. Suppose the register BX contains 4895H. Then the contents 4895H are moved to the CX register. Clear? After that, the CX, indirect addressing, base addressing mode. In this addressing mode, the offset address of the operand is given the sum of the content of BX or BP register, BX register, and 8-bit or 16-bit displacement. That is the move DX from BX plus 04. That is the BX is added with the 04. That is the displacement of 8-bit displacement. That is the transfer to the DX register at CL. C register, CL lower order address plus, that is BX plus 08. 08 is the 8-bit displacement. After that, index addressing mode. In this addressing mode, the operand offset address is found by adding the content of the SI, source index or destination index register, and 8-bit or 16-bit displacement. To the move BX, SI. After that, base index addressing mode. In this addressing mode, the offset address of operand is computed, the summing of the base register to the content of the index register. Base register to the content of the index register. Base index with displacement in this addressing mode. The operand offset is compound by adding this base register content, contains 8 or 16-bit displacement. That is the BX plus TOC. This addition of the BX plus display, that is the destination DI for, that is the SI, source index destination index plus 08. That is the displacement. That's all enough about the addressing modes of 8086 microprocessor. These are the 8 addressing modes in 8086. Any doubt, just call me.